In this lesson we're going to take a look at exponents, roots, and order of operations. And first we've got exponents here. So exponents are used when we have a number that's multiplied by itself multiple times. For example, if I have 4 times 4 times 4, it can be rewritten as 4 to the third power. And the power is just the sum of how many of that particular number you have. We call that the base. That's the number that's down here being raised to a power. That's called your base. Okay? And the number is called your power, or your exponent. It's also called your exponent. Exponents, powers are the same thing. Okay? So if I was given 4 times 4, now here there's only 2 of them, so I would write 4 to the second power. Now the reason why I show this second example is because the second power and the third power are very common, and we call them, they actually have names. So the second is called squared, and to the third power is called cubed. So you can read those as 4 cubed, 4 squared, or you would say 4 to the third power, 4 to the second power, respectively. Okay. Now in these two problems, I've got different amounts of the certain base. This first one with -6, there's 4 of them, so you would write -6 in parentheses to the fourth power. The second one, you've got 0.3, there's 5 of them, so we say 0.3 to the fifth power. Okay. Now it's very important with this first problem, the -6, that we don't write -6 to the fourth like this. These are two different answers, and we'll talk about that on the next slide. For example here, we've got -2 to the fourth. If I work that out, what I'm supposed to do is actually take the 2, raise it to the fourth power, and then put a negative in front of the answer. So what that would look like is a -2 times 2 times 2 times 2. And then if I work that out, I would get -16. And in the second problem, it would turn out to be -2 times -2 times -2 times -2. And then the answer would be +16. Because when you multiply the first 2, this turns positive. When you multiply it by the next one, then it turns negative again. But then a negative times that final negative gives you the +16. Okay, so it is important whether or not the negative sign is inside the parentheses or on the outside, like this first problem. And again, the difference is that in the second problem, the negative sign is actually being part of the power process, being multiplied out 4 times, whereas in the first one, it's just hanging out in front. Okay. Now the bottom line rule with negatives being raised to powers is that if you have a negative number and you raise it to an odd exponent, the answer will be negative. If you have a negative number and you're raising it to an even power, the answer will be positive. For example, if I have 3, -3, to the third power, that would give me -27. If I had -3 to the second power, the answer would be +9. Okay, so anytime you have a negative number raised to an odd exponent, the answer is going to be negative. Anytime you have a negative number being raised to an even exponent, the answer will be positive. And that holds true always. Now, as a final note about exponents, when they're written in the form that's spread out, expanded like this, even though it's a variable, we can still count it up and just write one variable raised to the 6th power because there's 6 of them. And of course it also works with fractions, like this one. I've got 2/3 times 2/3, so I write just 1/2 raised to the 2nd power. Okay. So this is called exponential expression when it's written as an exponent coming from the product. So we take the product, write it like that, and that's the exponential expression based on the product that was spread out. Okay. Now we're going to take a look at going the other way. Now you're going to see problems where it's written as an exponent and you're supposed to actually multiply it out. Now you don't always have to write it out, but in your head what you're supposed to be doing is checking the exponent and seeing how many there are of the base. And so in this one we've got 5 squared, which means we really want 5 times 5. And when you get that, you actually multiply it out to be 25. And then in the next problem, I've got 2/3 to the third. You want to write that out 3 times. 2/3 times 2/3 times 2/3. Now when it comes to fractions, what you're supposed to do is multiply straight across on the tops. So the 2 times the 2 times the 2, that gives you 8. Then you multiply the 3 times the 3 times the 3, and that gives you 27. And this is 2/3 cubed. And then finally we've got 2 to the 6th. So what that means is you write 2 6 times, and then you multiply 2 times 2 times 2 times 2 times 2 and times 2 again, and you'll end up with 64. Okay, so that's all it is expanding it and then actually doing the multiplication as many times as the number is spread out. Alright, now we're going to take a look at how negatives affect these. And as I said earlier, if you have a negative to an odd power, you'll end up with a negative answer. If you have a negative to an even power, then you'll end up with a positive answer. So we're just going to take advantage of that with these problems. So here I've got a negative being raised to an odd exponent, so my answer is going to be negative, and then I just have to figure out what 3 times 3 times 3 times 3 times 3 is. And if I actually multiply that out, I'll end up with 243. So the answer is just simply negative 243. So the negative part you don't actually have to work out, it's just you have to think through what I said at the beginning, or a little while ago, that if you have it to an odd exponent, the answer will be negative. And then there's no worries about the negative sign. And the same thing happens and holds true here for the negative 2 to the 6th, where the answer, because it's an even exponent, is going to be positive. So then I just have to worry about what is 2 times 2 times 2 times 2 times 2 times 2. And if I work that out, I'll end up with 64. Okay, and it's positive because the exponent was even. And then finally we come to this last problem here, where you can see there's an even exponent, but be careful, the negative sign is not included as part of the parentheses. See the difference, the contrast between these two problems. What happens too often is my students give me the positive answer here, when actually this means negative times 2 times 2 times 2 times 2 times 2 times 2. In other words, it means negative times whatever your answer was, which was 64. And that just gives you negative 64 without the parentheses. Okay? So whenever you see a negative sign outside, it means you need to multiply it at the end against whatever answer you have. Now that especially is important when you see a problem like this one, where you've got a negative and then you've got a negative on the inside being raised to an odd exponent. So let's work both our rules there. The negative sign gets multiplied at the end, so it's going to be negative times whatever our outcome is from this part. Now because it's being raised to an odd number, you've got negative 2 times 2 times 2. In other words, the answer would have been, just from the raising it to the third power, a negative 8. But we've got our negative sign out in front, so it's negative 8. Now when you have two negative signs next to each other, you change them to positive, and then your actual final answer is positive 8. So that's just about everything that we need to worry about when it comes to exponents.